The first milestone was to drive the car in the simulator using conventional computer vision methods. The second milestone was getting the conventional computer vision methods working in the real world on the car. We used a reinforcement learning neural network to control the steering of our vehicle. Our neural network consisted of 2 convolutional layers and a single linear layer. For better performance, we downsampled and pre-processed the input video feed that was given to the reinforcement learning neural network. Our neural network was trained inside of a custom simulation before being used in the real world. The reward function we implemented mapped the position of the car to a steering gradient. We used the steering gradient to drive in the simulator given the ground truth position. At epoch 0, the car knows nothing and defaults to driving straight. At epoch 50, our model has learned how to turn left, but not right. At epoch 156, the model has learned to turn left and right, but is indecisive. At epoch 250, our model has learned to decide what to do, but struggles to make multiple decisions consecutively, as well as make turns with short notice. At epoch 350, the model has learned to take turns given short notice and can decisively turn at intersections. At epoch 442, our model drove smoother and more consistent. This is the model we used on our car. Several of the first attempts at transitioning to the real world were not very successful because there were many differences between the simulation and physical system that needed to be corrected. We used YOLO v7 to perform our object detection. In order to improve the speed of our object detection on the car, we used a tiny YOLO model. We trained the tiny YOLO model with a custom dataset of over 2,500 images that we labeled to recognize signs and lights. The images we trained YOLO on were full-resolution images taken with the camera on the car. We gave our YOLO model full-resolution images to allow for better detection of signs and lights while driving. We used multi-threading to allow our reinforcement learning and YOLO models to run simultaneously. With them running together, we had an average frame rate of 25 frames per second for the reinforcement learning model and 15 frames per second for the YOLO model.